Topic B, sets. Now sets are unique Python data type that I really like. They're essentially just lists of unordered and unique items. So with a little bit more detail, we're talking about items that cannot be repeated. So an example is like a 1-1, that's a valid list, but that would not be a valid set because 1 repeats. And so sets, every item in there is unique. Now, because of this feature, sets essentially have the same properties as sets in maths, which we've done in, if you remember those Venn diagrams. So A union B, A intersection B, A difference B. As for what to put in sets, basically any valid strings or integers will do. So let's get into the programming where we're going to create sets, we are going to read data from them, and we're going to add new items and remove items as well. In this video, we're going to create 2 sets and then do basic operations on them. We're going to print the elements that are in the sets. We're going to iterate through them, add elements, and remove elements 3 different ways. So let's start with really simple examples. We can have set A and set B. So set A can have 1, 2, 3. Set B can have 3, 4, 5. And coming to printing elements, obviously you can do this. You can print what's in a set, and then you have 1, 2, 3. This is what's interesting. As I said, sets are unordered. That means no order, no index. So you're not able to basically print an individual element. You can, however, iterate through them. So for item in A, print item. No problem. 1, 2, 3. Now, adding elements. First of all, the easy thing to do is to a.add. And this is for a specific element. So A, we can add 4 to A, and then print A to see what has happened. So now we've added 4 to A. You can update a set. So if we did a.update, and as it says, self S updates itself with a set. So if we updated it with a B, and then we printed A again, we would have a larger set. Now, you notice that B had 3, 4, and 5, and A had 1, 2, 3, 4. Only 5 was added because every element has to be unique. And the elements that are not unique are just, well, ignored. So finally removing items from sets. This is the easy one. A.remove. So you can remove 5. No problem. Or when we print A, 5 is no longer going to be there. However, there is another option. You could have discarded 5. Let's see this. A.discard, and we'll discard 4. And now it'll be back to 1, 2, 3. Now, the difference between these two is, watch this. If you try to discard 8, which is not in there, you will get an error. If you try to remove 8, which is not in there, you will get an error. But if you try to discard 8, and let's go back to removing 5, watch this. No error, just nothing, no problem. If it ain't there, there is a built-in sort of exception mechanism for trying to discard things that are not in there. So that's why discard is useful. And there's also a.pop. Now, a.pop is interesting. I'm actually going to print a.pop, a.pop. And that is going to return the first item and take it away. So those are the ways that you can remove items from sets in 3 different ways. It interestingly takes the first item for the pop, and in other sort of data structures, it's usually the last item, but for sets first. So there you go, just a quick recap. We created 3 sets, we printed them, we iterated through the elements, we added some elements 2 different ways, added whole sets and just individual elements, and we removed items from sets 3 different ways. So let's look at some set operations and functions. Essentially, you'll see, starting with union, those 2 can be doing very much the same thing. So in terms of the Venn diagram mathematical notation, this is what a union is. You have a set A, you got a set B, you put them together, and then you have A union B. Now, this basically has all the items in A, all the items in B, and there are no duplicates. So if 1, 2, 3 was in A and 1, 2, 3 was in B, then, well, there's only 1, 1, 1, 2, and 1, 3 now. So let's have a look at what that means. So the number-wise, you have 1, 2, 3, 4, 5, 6, 1, 2, 3, 7, 8, 9, 10. See this 1, 2, 3 here? That more or less gets eliminated. So you only have one instance of 1, one instance of 2, one instance of 3. But the 7, 8, 9, 10 get added. And so A union B is that. In code, that looks like this. Given that A union B is the same thing as B union A, you can actually write A dot union B and B dot union A. But there is another way to achieve the same thing, and that is with that straight dash operator. So you have A and B here, and A union B is represented with this dash, and look at that. Exactly the same outcome. So let's look at intersection. So if you have two sets, A and B, the intersection of A and B are the items that they have in common. So looking at some examples, if A was 1, 2, 3, 4, 5, 6, and B was 1, 2, 3, 7, 8, 9, 10, then the only thing they have in common was those duplicates we threw away. 1, 2, and 3. 1, 2, and 3 is in A, 1, 2, and 3 is in B. So much like union, there is a function, A dot intersection B, B dot intersection A. They work the same way. And much like that dash operator, there is a special operator for the intersection, which is A and the and sign B. Next we have difference. So the difference in sets is basically what's in one set and not another. So if you think of the difference like A minus B or A difference B, is things that are in A but not in B. So we have to get rid of A intersection B essentially. That is the difference. So again, same example, 1, 2, 3, 4, 5, 6, 1, 2, 3, 7, 8, 9, 10. A minus B are things that are only in A and not in B, which is 4, 5, and 6. So B minus A would be things that are only in B, not in A, and that would have been 7, 8, 9, 10. So in code, guess what? Very, very similar. You could have used the operator, A minus B, B minus A, or A difference B, B difference A. So there is a possibility to get the symmetric difference between sets, which is the set of everything that is not in the intersection. So that is like A minus B plus B minus A, which are the unique items that are not in the intersection of both, and that itself has a function, A dot symmetric difference. So remember, the intersection of these was 1, 2, 3, right? And so 4, 5, 6, 7, 8, 9, 10 would be the symmetric difference between them. Next is subsets. And subsets are like if you have a numbers 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. They're all integers, so they're all like that list of numbers is a subset. That set of numbers is a subset of like all numbers, integers, for example. So here are some examples, like if you have A, 1 to 10, B is 5, 2, and 10. So when you say A is subset of B, that's false, because not all of these can be found there. But B is a subset of A, that's true. All of these, 5, 2, and 10, can be found in A. So you can basically say that all of the elements in B are a small part of what is in A. B is a subset of A. We can call A the superset of B. And for that, there is also a Boolean function, which is A dot superset B, and that would be true. Next, equality. Well, you can basically test sets with the double equals to or the not equals to operator. Here's an example. So you have A, and B is a copy of A, and C is just money and fame. It's just a set of two strings. So A is the same as B. That is true. They're identical. A is C. That's false. C is not A. Well, it is not A, and that statement is true. So one quick note. The copy method, as used on sets, produces a shallow copy of a set, much like dictionary's copy method. A shallow copy means that only references to values are copied, not the values themselves. All right. So that was all for set operations. And as you have seen, the operations are the same as those set methods. A difference or A minus does the very same thing. So let's see these concepts in code. So in this video, we are going to demonstrate set operations. Right here, we have created two sets. A is 1, 2, 3, B is 3, 4, 5. And then we're going to demonstrate operations like A union B, two different ways with a symbol and a function, A intersection B. We're going to test equality between A and B using a double equals operator, as well as subset and superset testing methods. So let's get started. A union B. We can just start by printing A dot union B. Run this, and right here we have the answer. A union B is 1, 2, 3, 4, 5, which is correct. You could have also printed it A, boom, line B. That is providing us with exactly the same answer. So just for the sake of making this look nice, we can print something like this. A union B. Two different ways to do it. For here, let's print A intersection B. And first, the function method. A dot intersection B in here, and that should produce the exact same result as A and symbol B. So when we run it, we should get 3. There you go. That's A intersection B. Now, A equals to B should be a straight nope. A double equals to B. That's going to fail. I mean, if we added 4 and 5, then A and B would be the same. So, subsets. Now, this will be interesting because we're going to have to modify A to make the B its subset, or modify B to make A its subset to be able to test this. But right now, A dot is subset B is going to be false because all of the elements of A are not to be found in B. So what if we changed A or changed B? So for example, B dot update, and the new B would now contain 1, 2, 3, 4, and 5. You could check if A was the subset of B, and that would be true. Regarding superset, if A is a subset of B, then B is a superset of A. So you can literally print out B dot is superset A right here, and that's going to print false. So I'm just gonna, in order to make our answers more clear, subsets and supersets. So just watch this. Subset supersets. A subset of B is false, and B is superset of A. They're both false. Now, you see how A subset of B is true here? Well, B is superset of A should also be true right there, and it is. So that covers everything. Just to reiterate, we calculated A union B two different ways with a function and an operator, A intersection B with a function and an operator. We tested equality with sets as well as the concepts of subsets and supersets, which are inherently correct. If A is a subset of B, then B is a superset of A. So, final note of the day, frozen sets. So far I've talked about a set like a list of unique items. Well, a frozen set is like a tuple of unique items, meaning that the items in a frozen set cannot change. Once they're created, they stay the same. So if you're using sets and for some reason that set data should be immutable, you can simply create a frozen set using the frozen set method, and then you're going to have this special feature. So this is how to create one. A equals frozen set. So you need essentially those round brackets or the square brackets on the inside, and you have a frozen set object. So that's all I'm going to do for that. No code really needed. They're a fairly rare feature, and pretty much as I said, it's just a set that you cannot change.